Hello, my name is Brittany Oweno from fourth period AP Macroeconomics. Alright, let's roll into it. So the question states, in Bermuda, the required reserve ratio is 10%. Assume that the central bank sells 70 million in the government securities on the open market. Alright, so obviously it's going to be about an open market operation. Okay, so the question states to calculate the total change in reserves in the banking system. So we know our DD is 7 million and our triple R is 10%. So now we just need to find the required reserve, which is easy as economics. So, yep, yes it is. So you're going to multiply your DD times your triple R to get your required reserve. So you're going to multiply 70 times 0.10 and you're going to get 7. That's your required reserve, and it's going to be 7 million. Now to find the excess reserve, which is it's actually pretty simple. You just, subtract two numbers. I'll tell you what it is. Alright, to find the excess reserve, you're going to subtract your required reserve from your demand deposit. It's pretty simple, yes. So 70 minus 7 is going to equal 63 million, and that's going to be your answer. So in total, you're going to add your required reserve and your excess reserve to get your total change in reserve, which equals your demand deposit. Alright, so then part 2, they ask you what is the maximum possible change in money supply. So the formula for this is actually pretty easy. You're going to take the ER and multiply it by your money multiplier, and then you're going to add your bonds/purchases. I know what you're thinking, what is a money multiplier? I'm going to show you how to find it. So now to find the money multiplier, the formula is going to be 1 over triple R. So as we've seen before in the previous problem, the triple R is 0.10%. So you're going to, divide 1 divided by 0.10, you're going to get 10. So plug this in the formula. Okay, so remember, our formula is ER times the money multiplier plus the bonds/purchases. So our ER is 63, our MM is 10, and our bonds is 70. So plug it in. 63 times 10 plus 70. And what's our answer going to be? Our answer is going to be 700, because 63 times 10 is 630, plus 70 will get us 700. Okay, so the base of this problem is about open market operations. And what an open market operation means is when the Fed buys or sells bonds. So understand, in an inflationary monetary policy, the Fed buys bonds, which increases the money supply and lowers the interest rate and federal funds rate. I know you're thinking, what is the federal funds rate? A federal funds rate is the loans that banks lend each other overnight. So that will actually lower it in an inflationary monetary policy. So when you're thinking about inflationary monetary policy, think of easy money, and the easy money always shifts vertically to the right. Think buy big. In single banks, which is also kind of referred to as investment banks, it's usually used for purchases of sales of bonds and stocks and other investments, while a commercial bank is highly regulated by a variety of federal authorities, like the Feds, of course. And we have regulations like the Reserve. In a contractionary monetary policy, the Fed sells bonds, which decreases the money supply and increases the interest rate and federal funds rate. Think tight money, and tight money always shifts vertically. Now on to our last problem, problem C. It asks, what is the impact of the central bank's bond sale on the equilibrium price level? So now that we know that when Feds buy bonds, it's going to increase the money supply, that will be our answer. When the Feds buy bonds, it will increase the money supply. That is your answer.